everybody. Welcome to the weekend. Welcome to the weekend.
The ugly truck hammers, alternator screams. He got his amp running lean and mean. As the signal reaches coast to coast, his amp builds are better than most. He's got zero reflect. No fancy shop, just his iron and fire. Dreams wired up with quiet desire. Each amp a beast, a story told by hands that build, not hands that fold.
Alrighty. We're ready to go here. Alright, let's see what's happening here. Friday night here in South Jersey. I am going to show you guys quite a bit of stuff here tonight. And it's interesting that someone actually did on a post, one of the videos I just did. What happened, what was said, was I didn't show the peak of the radio. And then, you know, he progressed to tell me how I should have hooked up my stuff. But that's alright, I have a lot going on. And during these tests, guys, you have to understand that I built the equipment, I ordered everything and got what I had to. I built the equipment. And then I take and I set this all up for I can show you guys a video, and I'm doing this all by myself and no one's really helping me take and do the video and do the narrating and remember where everything is. So, hi Annie, how are you? My sister. Let me get a different pair of glasses. So, as I was rambling on about, I am human, so if I make mistakes, it will happen. If I miss a test, it will happen from time to time, and it's not always the best thing. What did I want in there? That one. Alright, got all that hooked up. Alright, so here's what we're going to do. I'm going to take the radio directly into the dummy load. Right here. We're going to look at a 100 watt slug and digital Dave on RMS and peak. Now this is just a radio. Now this is a brand new R&R radio out of the box. I think I got it about a year or so ago. Great radio. Only thing I had them custom do for me is put an echo. This radio is not one that I planned on running on my bench all the time, but it's here for now. So everybody knows Dustin does a hell of a good job on these radios, and I'm looking at guys right here on this list in front of me, and they have his radios, and he knows that he's a badass radio tech. Now they say, oh, these radios do too much power. Well, this is going to clarify a lot of that, as I'm showing you from the distance of how much power this radio is going to produce, an RMS and peak. But there's a variable to that, and it's all from where your dead key is controlled from. So if you're all the way really far down, you're not going to see full output of this radio. All right, and that goes with the same saying if you had a potentiometer and an amplifier. Same difference, okay? So a potentiometer or a dead key adjustable dead key on your radio will affect where you set your dead key and what would be the maximum output swing. Hard to go from 0 to 100, guys, and you all know it. You can't expect a radio to take and have a very, very low key and make full output. It's not gonna balance out very well. All right, there's guys out there that can do that with radios. Those radios normally don't last very long. All right, so let's just look at basic performance on this radio. So let's look at the carrier level right here. I'm going to key up. Now look at it as an RMS. Let me just toss a slug over here. We'll just use this little guy. Okay, so I just put a 25 watt slug in there for RMS. You know what? I cannot do that because I will max it out. All right, here is your RMS digital, and this is just a radio. Now, guys, this is about this amplifier, but this is truly about to help people out there that may not understand what a free running radio will do. Now, this is a free running radio. There's nothing, it's not doing anything but getting to my dummy load. That's it. All right, here you go. There's a 100 watt slug. It's in a 100 watt position. RMS. 1, 2, 3 audio, 1, 2. Wow, that radio did 9 watts. All right, carrier's really low. Let's take a look at that. So low, it's not even registering. There's 1 watt. Audio, 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 audio. All right, 1 watt hitting 10. RMS. Let's see the same. Picking up modulation, I guess. 1, 2, 3, 4, 5, 6. Audio 1. Just trying to stabilize the number. Audio, 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 and here's your RMS up here. Audio, 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 audio. So it's like 9 up there. Not all the slugs are going to stay the same, but this is a 100 watt slug, and I'm showing you peak power out of this radio with about a 1 or 2 watt carrier. Audio 1, 2, audio 1, 2. Regular talking. All right, let's look at RMS again. 2 watt carrier, audio 1, 2, 1, 2, 9, 10 watts. All right. So they said, man, that radio can do a whole lot more. Absolutely can. Watch what happens when you take and crank something wide open with no control. Now she's saying it's dead into the wind right there, all the way in. Let's look at our carrier. 11 watts. We're gonna go forward, guys. 1, 1, 1, 1, woo, wah, woo, wah, 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 wah. 14 bird, 15 bird. Peak. Here, let's go up here and look at this bird real quick. Make it a little larger. Get some of that audio, 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 audio. Not swinging very much. That's okay. Ain't changing a thing. Look at the peak. Peaker tweaker, audio, peaker tweaker, audio, peaker tweaker, audio, peaker tweaker. So now we just went from a radio that was doing about 1 watt carrier. Audio, peaker tweaker, audio, peaker tweaker. All right, so I'm at 60, 52, 60. And this is free running into this dummy load. No amplifier driving, audio, audio. All right, so now we got that totally out of the way. Now, people sometimes ask questions and they may not be ready for everything I throw at them because I am bringing this all the way from the bottom. Starts here, it's your brain. It makes everything work on the bench. So if you have a radio that's not functioning properly, you're not going to get your bench to run right. You're not going to get your mobile to run right. Definitely ain't going to get that base station to run right. So make sure your radio is performing right. Now, again, this thing was just freewheeling. It was not driving anything. It had no pressure. It's just like you're breathing. That's how this radio is running. Now, we're going to take and introduce a driver to this in another box. So what happens there? You have phase angle. You have coaxial phase angles. So if the coax phase angle is incorrect, the amplifier is definitely not going to work right. The radio can't get out to the antenna right because you created your own little fashion of a standing wave or a reflection between A B, C, and D. All right, so if you guys can take and stomach all that, now we're going to see the same super great performing radio drive, and we'll be able to control the Texas Star, and we're going to use the same thing to drive the 4. All right, so let's take and hook up some coax. Give me a second. All right. So I'm gonna go over here. Get this slug back up out of here. All right. 1,000 over here in this hole. Woo! All right. Now let's line this next one up. Turn on power supply. Let's get them all going now, and I won't have to deal with it. Okay. Yeah, a pretty good group in here. I just looked up in the corner. I got 20 Facebookers in there, 10 YouTubers, man. Thanks for hanging out with me for a little bit, guys. So, moving forward, not leaving off where we were on our test. Let's cut this off. Let's cut this off. Now, we're going to be going, it's still over there, right there. We're going to be going through this equipment now, through that bridge, meaning the bypass tune on that amplifier there. And then also there's another one here, so there's 2 of them that radio's got to cross 2 bridges to get to the glory hole of the 50 ohm dummy load. All right, so let's take a look now where we are at again. Let's take and just go right back to this. Double check where we're at, 100 watts. Okay, so we're back down low on a carrier. Let's see where our output power is. Going through everything now. We're close to 10, I think. Audio, 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 audio. I lost a few watts in RMS. That's on the low end of it. Let's look at that high end of it. Audio, tweaker, 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 tweaker. All right, so we lost a little bit. Let's go all the way back up here. Man, this thing was really ripping on peak. Let's just go right here. Audio, ripping on peak. Audio, 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 audio. So there's like 10, 12 watts missing there. And let's look at RMS here. We were keying like 11 before. Audio, 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 audio. So not really missing a whole lot. Let's look at it one more time. Audio, 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 audio. A little bit, all right? And that's going through the pass through or the relay passes to get to the dummy load. So that means everything is cool and it's working there. All right, now let's disable this little guy here because I don't want to beat it up. In fact, yeah, I'm just going to take and shut that one off. And we'll go over here to the 2500. We'll be reading on that one and looking at 1000 and 2500 here. Now, I'm going to show a 250 watt slug for your input drive level, and then we'll use 25 watt as input reflect, and that's going to take and show you the communications between the 4 and the 2. Now, 4 transistors, 42879 HGs with 1-inch output transformers. Now, this is part of the South Jersey line. No, they don't. I don't really offer them too much with the smaller boxes with the 1 1/4 inch. If I did put them in there, cost more money, yeah, I could, but this is the South Jersey line. This is a budget line, so it's doing exactly what it's supposed to as far as the watts go. Now, if you want more watts, you simply just buy an upgraded version of a 4. Buy it. I would say buy it first instead of saying, oh, I bought this one, but I should have bought that one. That's why I normally talk to people on the phone to see exactly what's going to be the good fit for you. So, with that said, here you go. This is the little unit, little 4.5 cabinet, 120 millimeter, 106 CFM fan kit that I like to jam in these little cabinets. They'll stay cool. Now, as far as drive level goes, that changes when you change the dynamics of an amplifier. So, these not all amplifiers are built equally, and you say, oh, I put 100 watts in my 4-pill, why can't you put 100 watts in this one? You're limited. And you're limited here. It's kind of like a small block and a big block. But you still have the same transistor, same pistons, but you can control what's going on around them by different size and different values of parts. So let's get into this one. Let's just key this one up all by itself with just the radio. We're going to look at the performance of it. We'll look at the performance of this one. We're going to run this test at 14.8, 14.7, 14.8. And this is no driver, none at all. We're going to start with just a carrier of some sort. And we're going to see where we're hanging out at. Alright, here, one more time on the slugs. Look at 2500 watt on the digital, RMS and peak. And we'll look at a 1000 watt and a 2500 watt on the analog, 2500 watt analog and peak. Alright, here we go. Let's just take and check out the amps real quick. ThreeMate said something here. Most of the time you see you run your radio at 12.5, not 14.5. Actually, I used to run at 14.9. A lot of times if you saw it at 12.5, I was really rolling them back because I was really trying to control something. So that's why I have variable voltage on my radio. Alright, here we go. Here's your amperage. Audio 1-2, amperage, amperage, amperage. Now this is just a radio driving 4 transistors, 1-2. Now that's at 29 amps. See what we've got here. Audio 1-2, 1-2, 1-2. 14.9 is showing 31, 32 amps there. So either way, here or there. This is going to be input reflection. Audio input reflection is 25 watt slug, a little under half watt. Let's take a look at the 1000 watt scale. About 180 watt carrier. Audio, 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 audio. So about 210 watts. So what happens over here on this side? Each one's 50. Audio, 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 audio. This is 2500 watt scale. Audio, audio. So about the same, 210. Now let's look at the digital. Audio, 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 audio. 225. Now, that's with a standard carrier and just that radio driving it. Here's your peaker tweaker. Tweaker and a peaker. Look at the digital. Digital audio, peaker tweaker, audio 700 watts, 650, 700. Let's look at the analog real quick. That's just 4 pills. So you look at why is it doing so much peak and not so much RMS? That's the peak right there. I'll come over here and hit the RMS, and there's RMS. Why is it doing all of that? Well, if you take a calculator and figure out that's about 2.5 times more over RMS. So let's just see that. Let's see if it adds up right. Let's take a peek real quick. So we had what did we just say? Let's take a look at RMS. Audio RMS, audio. So we'll just call it 2.5 just to be happy. So it says 562, and maybe it's 2.8. What did I just say? 225. So it says 630. Let's see if we can make that. Audio, 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 a little bit here and there. All right. I can't control that. I'm just modulating. All right. Now that was with that right there with low carrier. Remember how this radio really performed? What happens if I just took this radio and threw a big carrier like that, wide open, drop 10 watts in it, right? What do you think is going to happen to the box? 1000 watt slug. The radio deck is like 10 watts, right? Wow, look at that. That's full output of that unit, and then some. I'm not modulating because that's 340 bird. Now, what do you think? It's going to back up? Audio, back them up. Sure did, back them up. Like Jimmy. Watch this one. Audio, back them up. Now what happens here? This sucker better not go backwards. It's peak. It should never, ever, ever, ever go backwards. Never, ever, 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 ever go backwards. That's why if you got all your peaker tweakers in one basket and you don't mind RMS, you say, oh, I never go to RMS. I'm a peaker tweaker. I'm a peaker tweaker. You're backing your stuff up. You can't see that in peak. Here, watch. Watch right here. Yeah, peaker tweaker. All right, I hit 750. I did more. And back this thing up. Oh, peaker tweaker audio. I gained 50 watts because this thing really got up and skedaddled up there in the peak. when you had that wide open, but down here where you're controlling it, it's controlled. It's limited with the modulation. Audio, finger twigger, audio. Going forward here, audio. All right. So, sorry this may be boring to some of you guys in here, or you're all actually just learning a lot, I'm not sure. But that was just the 4 transistor with just a radio hitting it. Now, we got to watch what we're doing. We have to watch what we're doing right here with this carrier knob. So let's take and go and look at what this thing does. Cool? All right. Potentiometer is a great item to have. Now, if you have a radio that doesn't have a control for your dead key to bring it up and down, because that's all it really does, when you crank it wide open, your radio sure will do a lot more power, but you can't run your stuff like that, guys. So you got to take what you have. So if your radio technician's good from a low takeoff point, it should top out really nice at mid-scale. You should have plenty of swing. And let's just take and see how this radio is going to affect this amplifier at this point. All right. So let me see if I can even get a carrier on something here. Where am I looking? I'm looking over here. All right, here we go. So this is a 250 watt slug. And we're going to take a peek at this meter right here. All right, it's a 250 watt slug. So right here, I'm really not jamming up the amp really much at all. Audio, audio, audio. So we're hitting about between 40 and 45, 42 watts, 35 and 40 watts. All right, so 35 and 40 watts out of Texas Star. You would think that you would pull somewhere right around, you would think I'd be talking right around times 10 the input drive level, and it does track pretty close to that until you run out of room to feed it more drive. And that's what we're going to get ready to start discussing at this point. But before I do that, really quick, the phase angles of this system that I'm running here on the dummy load is I'm running half a wavelength from that radio to that driver amplifier. A half a wavelength. Now if you want to give it a number, it's 12 foot or so in 0.66 family. Alright? The velocity family. And then I'm running 12 or a half a wave out of this into my dummy load, and the dummy load goes to the 12 as well, etc. So it's 12 or a half wavelength and a half wavelength and a half wavelength out. So that's your phase angles for this. So let's take a peek what we got going on here now with my drive. We're doing about 40 to 35 to 40. Audio, 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 audio. So as you see that there's just a little bit of power, just a little bit, that just creeped in. The circuit is being ran. Why did I lose that little bit of power right there? Audio, 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 audio. You see that? I'm at 45 watts of drive. If I cut this unit off, audio, 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 audio. So it's just a tiny bit. That tiny bit is what's happening here in my bypass tune of the amp. Audio 1, 2, 3, 4, 5. That's the bypass tune of the amp. So that's what that's eating up. So when you lose it here, you lose it there. You lose it somewhere. You're always going to lose power somewhere, especially if you have some sort of reflection, and there's reflection everywhere. All right. Speaking of reflection, here's your input reflection. 1, 2, 3, 4, 5, 6, 7. That is a 25 watt slug. Audio 1, 2, 3. So we're hanging out right under 2 watts. Let's take a look at the 1000 watt slug. Each line's 20 watts. Now this is the low drive, guys. This is like if you were to have a striker, and everything's setting out right about 14.5 or 7, somewhere in there. Audio, audio, audio. This is RMS. Audio, 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 audio. So we're hanging out right about a little better than audio, 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 right about times 10. Not there. I'd have to pull 450 to get that times 10. Audio, 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 audio. Now, does this help? Does that help? Let's find out. Let's find out. Everybody does this. I don't. I don't go after 12. Let's see. Did it help? Audio, audio, audio. Sure in the hell did not. I just probably picked up everything in the background. So, my gain normally is somewhere between 11 and 1 o'clock, where most of these radios like to run. Alright, so we're putting 42 watts into this. We have a really good input reflection. Audio, 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 audio. Right around 2, 2.5. Let's look at our amperage. Audio, amperage, amperage, audio, amperage, audio. 47, we'll call the high number. All right, here's your RMS one more time. Audio, audio, audio. All right, let's look at RMS right here. 2500, each line's 50. Audio, 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 1, 2, audio. So we're closer to 450 there. All right, let's see the digital. Audio, 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 audio. 400. Now, there you go. Peaker, tweaker, tweaker, tweaker. Here you go, peaker, tweaker. 2500 peaker and a tweaker and a tweaker and a peaker and a peaker and a tweaker, a little over 1,000 up there, and we're at 975 right here. Audio, peaker, tweaker, tweaker, tweaker. Now, I'm trying to beat a dead horse, but that's how it goes. So only way you are going to increase power is what? Drive. Now this is where you guys can overexhaust your boxes really quick. Why can that happen? Is because of voltage. Voltage at this point is your friend. If you have way more driver than what you need, technically to do this test properly, I probably should have used a 1 transistor unit. So I am typically getting more peak out of this 2 transistor unit. Why? Because there's a lot more headroom in these 2 Toshibas that are in this unit. All right. If I had 1 transistor, I'd have this much headroom. If I have 2 transistors, I have that much headroom. Can I control it to do the same RMS? Yes, I can. But what happens to my peak? A lot of times my peak will be greater, and I'd have a lot more headroom with the peak versus RMS, because I'm controlling RMS, and this will control the peak a little bit, and it will follow, but as we know, peak likes to fill up really, really fast. So the peakers, the guys that love peak, man, you can take and have them run your equipment down to minimal power, see a huge peak number, but your RMS number is suffering, and that's what we're talking about right here. All right, here's your RMS number, and I'm driving, again, I'm driving right here. Audio, 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 audio. There's 45 watts, okay? Now, here's your RMS 45 drive. Audio, 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 audio. 400, okay? Now, if I increase my drive, let's do this, I'll show you. Audio, audio, audio. So it shows 45, we know we're hitting that. We're gonna turn this up a bit. Audio, audio, audio. So there's a, right at 60 watts. All right, so at 60 watts, see what we're using. Audio, 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 audio. We're right there at 60. Well, let's see what we're doing on our inputs. Audio, 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 audio. We went up just a touch. Now we're about 3, 3 1/4. But what happened to my RMS at 60 watts drive? Audio, 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 audio. So I'm hitting 460, 480. Let's see what we're doing here. Audio, audio, audio. 450 there. Let's see the peaker, tweaker. Peaker, tweaker, audio. Same number. Imagine that. I touched just a bit more. Audio, audio, audio. So it showed me 1,000. That's about all the growth she has. Audio, 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 audio. So there's a good 1,000 up there. But let's take a look at something real quick. Where's my peak at on this? Remember I just said a 1 transistor will have so much peak and so much RMS. Now we see the RMS. RMS, audio, 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 audio. So it's showing like 75 on that one. Let's see what the peak is. Now this is free running. This is running through the box. Audio, 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 audio. 2 to 225 on the peak. Let's see what it says up here. Audio, 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 audio. A little greater up there. So keep that in mind. When you increase your peak, you'll have a higher peak envelope power than your RMS. But like I said, to do this test correctly, I should have probably used a 1 transistor unit, which I don't have around here. So I'm using a Texas Star. So if you take and you start thinking about, if I drive this harder, am I gonna take and make more power? You absolutely will not on peak. Now, I'll bring the drive level up safely. I don't suggest you guys to continue to do this on your own at this point. Let's see where we're at. Audio, 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 audio. So it's showing me about 60 right there. Audio, 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 audio. All right, there's 70. And that's running 70 into it. All right, here's your RMS. Audio, 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 audio. I did not gain but maybe 20 watts. I hit 480. What happened here? Audio, 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 450. Didn't gain nothing hardly. Why am I peak? We're hitting a good solid 1,000. Audio, 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 audio. Not enough to take and chance it. You're out of voltage. Audio, tweaker, 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 tweaker. Totally out of voltage. You can't make any more drive into this unit because you're going to break it. Why? Because you don't have any more voltage at the back end of this unit. So if I leave my drive level right here and up my voltage about 3/4 of a volt, not even a whole volt. This is only 3/4 of a volt. Now watch the difference on what happens to your RMS and your peak. And we'll go down and look at the amperage here in a minute because I kind of forgot that. Here's your RMS. 1,000-watt slug. Audio, 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 audio. 540 burn. Now here's our voltage. Audio, audio, audio. 15.7. Here's your amperage. Audio, audio, audio. 58 amps. And here is your RMS again. Audio, audio. 525. And what happened to our peak? Did it grow? We were hanging out around 1,000 before. Audio, audio, audio. We picked up 100 watts for 3/4 of a volt, and we picked up about 40 watts RMS. So that is truly the ins and the outs of where you need to be and how you figure it out. Now, going to look at the drive level. We are what I call maxed out drive into this particular unit. Audio, audio, audio. We're at 70, 75 watts with that on. Now, if I turn this on real quick, let's take a look at her inputs. Audio, audio, audio. So she's up around 3.5. That's not terrible, but it increased. And when your input reflex increase, then the only thing that's going to happen is you're going to create heat. Now, I'm going to keep that level of drive real quick. And let's look at our input reflection now with lower voltage. With lower voltage now, at the same drive level. Alright, let's take a peek. Drive right quick. Audio 70. Input reflect. Audio, audio, audio. See, now we're at a good 4. So, what did that tell you? I literally gained an extra 1/2 a watt of input reflect because the power couldn't get out of the amp due to I didn't have all the voltage on the back end to let that amount of drive go into this thing. So I'm just going to try to do this. I don't know how well it's going to work. See if I can set the camera up. I don't think you guys are going to be able to see it well enough. I don't think so. Let me think. Alright, this should be enough to do it. Okay. So everything on, we're going to take a look at. I'm going to watch with you. Audio, 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 audio. Alright, you can see everything moving and everything working, everything going. Now, I'm at 14.8. Audio, 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 audio. So that's 70 watts of drive right there. Alright. Now, how do you figure out where you're at as far as what's happening here? Because you can bring this up and down, and it ain't gonna make ain't too much of a difference. So watch, I'll leave it where it's at, and I'll back it down. Audio. One audio. So we're at a good solid 975, right? But did you see right here what happened? Look at my drive level. Audio, that's 45 watts. 45 watts gave me an RMS, since this is easy to read. Audio, 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 400 RMS. It gives you the peak of audio, 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 950 to 975. All right, cool enough. I'm down here at 45 watts of drive. Audio, audio, audio. See, now I'm going to pick it up. I'm going to bring this up. Audio. don't see that peak increasing, do you? It's not. Audio, no increase, right there is a little bit. Audio, audio, 1,000 watts. Audio. I'm plugging 75 watts into this to do that. So if you look at this, audio, making 500 there. Audio, 75 watts of drive. Now if I roll this same back a little bit, audio, there's 50 watts of drive. Audio, 425. So we lost 75 watts. But our peak, everybody loves peak so much, here you go again. Audio, it's the same. So you guys have to determine how you choose to run your station and run your amplifiers. And it's the best advice I can give you. This is a really good breakdown of what's happening here. So when you're out on the air and you can only talk for maybe about 8 minutes, you're running your stuff too hard. It's getting too hot too quick. I know most of you guys already seen this before. You can run a piece of equipment to the point where you lose power. It's so hot that everything's totally saturated and you're losing power. That's no good. So mind you, you might want to keep an eye on your temperatures on your equipment as well. But with that said, if I ran this thing right where I'm at, audio drive, 45 to 50 watts of drive, I can produce this much power. Audio. Just touch 1,000. See the RMS. Audio. 400 to 425. Now, if you have just that little bit of extra voltage, believe you me, you can put it in and it'll be fine. But you have to have a good standing wave. You have to have the proper jumper lengths. And if you don't have those things, I highly suggest you do not turn up your amp as far as the voltage goes, because you're going to probably break something. So leaving the drive right where I was at, I increased 3/4 of a volt. See what happened to my drive here. Audio. Just a touch over 50 now. Look at my input reflection. Audio. Hanging out right around 2.5, just a touch over it. Let's look at his RMS right here. Audio. 450, and here you go to peaker tweakers again. Audio. The amp must have cooled off just a little bit, guys. I didn't check for heat. It's got a little bit of heat, not much. But anyhow, any way you want to cut it, this is running really, really nice. No, it didn't cool off. I have a little bit more voltage on it. That's what's going on. I have a little bit more voltage rolling across the circuit. So let's take a peek at the amperage real quick while I'm sitting here. And here's your amperage, and here's the voltage we're running. Audio 12, 49, 50 amps. We'll just call it 50. Here's your voltage, guys. Audio 15.7, and here's your peaker tweaker number. Audio 1, 2. Go with 1050. So do the math on that one. It'll come up pretty good. Let's see what it says here. What do we have again? 16.7 there. Audio 7. 15.7. 15.7. Audio 1050. 15.7 amperage, that's what I want. Sorry, 50. Audio. It says 800 peak. I think I'm blowing that out of the water a bit. Audio 1, 2. If I back off the microphone, I can get about 800. Audio 1, 2. But again, looking at this headroom of the peak coming out of the 2 transistors, you have a lot more audio growth. So your peak will be a little bit larger than sometimes the calculator add up. I could be wrong on that. I'm sure somebody will cuss me out about it eventually, but maybe I'll learn something. What's up, Lou? How's Florida life, man? Hope it's not too hot down there for you. It's pretty nice up here in Jersey. Anyhow, where my girl went, let me go find her. What's happening, Molly? How are you, honey? How's things? Mozilla. You gonna sit? You're creeping. What's up? Hi. You gonna wave? You're snuffling. Hi, how are you? It's the weekend. Welcome to the weekend, Molly. Say, roll, roll, roll. Very good. Welcome to the weekend. That's what you said. You wiggling your tail, too? Are you feeling good? What'd you have for dinner? Yeah, you had your special diet food? You had a couple little bites of... Yeah, you cheater. You had some pizza, didn't you? Didn't you, Molly? Yep. So what are you going to do this weekend? Got any plans? You don't know? Maybe find a pig ear? Maybe a kitty? No? Hey, hey. It's a magic word. You going to sit? Hi. You going to wave? You going to wave? Give me a wave. Molly. Hi. That's a good girl. It's your song. It's your jam, baby. You going to sing? Yeah. Yeah? Oh, you cuss. Oh, no. He said MFer. He said MFer. Oh. He shouldn't say that. No. Oh, I know what you want. A roller? You want a roller? Here we go. Where are you at? You ready? Come here. Come here. Come here, Linda. Come here, come here. Sit, sit, sit. Are you ready? Watch it. Watch it. Get it. Get it, Molly. Get it. Get it. Get it. Good girl. All right, guys. Well, there you have it. One little 4.5 transistor size cabinet. 4.5 cabinet, I should say. 1-inch output transformers. This is part of the South Jersey line. This is part of how I created the circuit for this. Trying to keep it up to somewhat of a budget. I mean, yes, I could build you guys custom amps and I could build a lot more power out of the same 4 transistors, but this is what we're putting down on a special. You guys are getting them. Everybody seems to like them. So as long as you use them correctly, they'll last you a long time. As far as guys running around saying, you can't drive these like this, you can't drive these like that, you can't volt these. You can definitely volt these things up to a certain point and expect to have good survival rating. I think if you guys hang out under 16 volts, anywhere from 15.8 and down, you're going to be fine. You're not going to blow your box to the smithereens. I don't suggest you put your driver on there because typically you have a big enough driver, so you normally would have to back the driver down. A lot of guys have that much control of their system where they can roll the driver back a little bit, and I highly suggest you do. You don't have to run a full bore open. Back in the day, oh, I got Toshiba 2x4, all 2879s. If they weren't such a good part, they would have died quickly. Now, I'm not saying the HGs can't handle that, but unfortunately, I haven't seen a 2x4 run worth a darn since I've been even building with these. So as you notice, there's no 2x4s on my list. They just typically don't work out very well. And I can get a 1 driving 4 to drive better than a 2x4. It would have, man, we're talking 2x4 with maybe 50 watts higher. It wasn't enough to even write home about. But you always need a bigger amp. You just get a bigger amp. Try not to take your little ones and make them into something they're actually not. So we're all guilty of it, including me, especially the shootout guys, man. They're notorious for doing things the wrong ass way, but they're on their own dime. They're doing this. They're learning good, the bad, the evil. Well, hey, a shootout guy, believe it or not, will learn a lot quicker about coax, standing wave, coax or reflection, coax lengths, and drive levels. They have to pay attention. Why? Because they're at the tippity top of the voltage line on these things. The 2879Cs, we put 22 volts in these units. They say you can't go over 22 volts. So a lot of guys put their stuff at 22 volts, and normally their system can't hold 22 volts. It'll drip down to 21.5 or 21 or even 20.5. It just depends on how their alternator system and their battery pack system or whatever they have will hold for what equipment they have. But if you have small equipment and you put it on 21, 22 volts, your system's not going to sag, so you better mind your drive. And that was a big thing that went on for the shootout. when we came out of 2020. We skipped 2021, and then the 2022 pills came out, HGCs, and everyone's like, these are terrible, they don't work, they blow up easy, da, da, da. They're not like the old 2020s. They're not. The 2020s were the absolute best transistor that HG really did put out, but as far as drive and forgiveness, or stupidity, let's put it that way. But where we're at today with the 2879Cs is way closer than a Toshiba. We always tried to strive, our baseline was a Toshiba part, and if anyone ever talked to North, please don't even mention Toshiba to him, because he'll just darn near hang up to you on the phone. He don't like it. He don't like to use, they don't like that comparison. So keep that in mind if you guys ever have a conversation with that guy. But the 2879C, the 2020s, they were excessive drive. They could handle excessive amount of drive, and I really wish I knew what they did with that transistor for that to happen. But when you get to a point of drive, and this goes to date. Recently I watched a video of absurdly amount of drive going into a 2-pill and or a 4-pill and or an 8-pill or what have you. The peak numbers were Godzilla numbers, but the RMS numbers were suffering severely. And if you look at the voltage and the amperage, it don't add up. Yeah, there's a lot of headroom, and I just said it and I just proved it in peak. What happens with headroom, you have this much drive, you have this much headroom with peak. And you have, let's say, this box, and it can accept so much drive, and it can only accept so much headroom in peak. And after that, it's full. What happens to all the extra power? It creates heat. That's where a lot of heat comes from. And that means all the power is not leaving the box, because you're saturating the circuit so grossly that it's just heating up the base or the input of the transistor, and the power has nowhere to go. It can't get out here. It can't get out here because everything's already too hot, because you're over driving. So and then if you add bias to an amp, it's more insult to injury, because if you have bias to an amplifier, you definitely do not have to drive the amplifier as hard as it were if it were in class C like this one. About half. To be honest with you, if you have bias, you should have to drive this unit about half of the power. So if we use 60 watts at maximum drive, 30 watts maximum drive with biasing would give you full output of this unit. But the problem is, no one can follow those directions. And they sound like garbage on AM, but they said, Johnny says I have to have biasing for sideband. Okay, Johnny, good for you, because you got a junky radio, and yeah, you need that bias to get that amplifier going. It's not going to make you sound any better. Remember I said at the beginning of the video, that is the brains of everything that's happening with this. This is the mule. That's why they call it a mule, or a jackass, or just a dumb amp, or a foot warmer. Didn't have no brilliant name like, this is the flux capacitor. But anyway you cut it, when you overdrive something, in return you make heat, you make reflection, and that creates more heat, and it just compiles, it gets clogged up, and the power has nowhere to go. Because why? You're dumping so much power in the input of this unit, with or without biasing, it just can't accept any more power. The only way it can accept any more power is if you had more voltage. And that's really not the wisest thing either. Smart thing is to increase your voltage and leave your drive level where it's at. Where it maxed out on the last level, don't touch that drive. Leave it right there at 60 watts, let's call it. And go and turn up this box. 3/4 for 1 volt. Now it can breathe again. The input standing wave goes down. We just showed all of that. So I'm really proud of everybody that hung in here with me. 16 YouTubers and 10 Facebookers, 12 Facebookers. And really thank you guys for coming in and listening to my rant about overdrive. This is from the front to the back video. So I'm really proud of you guys that hung out and watched the duration of this video, for you can kind of see it. It wasn't a super box. It wasn't some flattering numbers or anything. This is very conservative and smartly ran and thought out about, because as I was building this unit, I don't have to think too much about what I'm building. I have to think about how can I present it to you guys, for you're going to understand how not to break it. I don't like to do repairs. I have guys that call me up and say, listen, Danny, I broke my box. I really hated to take and make this phone call to you. I said, what'd you do? And he goes, you're gonna kill me for this one. I had an export radio, and I thought I shut the driver off, and I was gonna dump it right into the other bigger box, and I didn't, and it just plowed right through the box. Well, that happens. And I suggest anybody that would have a 2-piece system or even a 1-piece system, and you have one of those great export radios, definitely wouldn't run a 1-piece system if you had a driver inside. Do not, if you got a switch, you can cut it off. I would not run that high-powered radio into it, because at one time you forget to hit that switch and cut it off, and you key that radio up, you kiss that amplifier goodbye. Guarantee it. Something's going to let go on it, or you're just going to make it into something that don't want to function properly for the rest of its life until someone's smart enough to figure out what you did to it. And typically you damage the transistors, and you don't want to do that. So get a good common radio. Obviously Dustin can make a wicked radio. Yeah, you can get them from ICA Manufacturing. I think Carl Built's got them, and a couple other vendors have them. The Dustin R&R radio is a great radio, and he does a good job on them. He's very thorough on what he does. But again, when you get a radio like this and you freewheel it and don't have amplifiers in line, man, that thing's going to show you the moon and back. But now you introduce a lower dead key, let her eat, let her swing, controlled into your driver, control into this or your next piece, and that big giant honker radio won't do that. It'll behave. It's kind of like an Ultimate Fighter, man. They can go rip a man's head off, but you bring them out in public, they can pretty much behave. So it calms down when you take and roll the carrier level down and get it right where it's supposed to. I mean, our motors in our cars can make so much horsepower. Do we use it all the time? No. We govern it with what? Our foot. And if you don't, then the police will give you a big fat ticket. So there's a lot of information in this video, and again, thank you guys for hanging to the end. On the ones that did, the guys that shot out early, they probably missed some pretty important stuff. Maybe they'll catch it on the rerun. But I'm going to slide out of here. Thanks for watching. Welcome to the weekend. Here's a little South Jersey 4-pill. Not bad. All right, guys, I'm out of here. You say bye-bye, Molly. Come here, say goodbye. Come here. Linda, come here. Linda, come here. Molly. Come here. You gonna sit? Gonna wave bye-bye. Bye-bye, Molly. Yes, bye-bye. Yes, come up here. Come on. Give him a close-up. Give him a close-up. Look at your nose. Look how pretty your nose is, Molly. You love that. You good girl? Say All right, goodbye. Welcome to the weekend, guys. I'm out of here. God bless.